You want to know the secrets of clean audio? They're called signal flow and gain staging. Hello everyone, and welcome to WaveSpot. My name is Austin Knaus, and I spent the last 2 decades working with audio. My goal for this channel is to share all the fundamentals that I've learned along the way in hopes to give you a fast track to understanding the world of sound. So, let's dive in. Oh, the joys of signal flow. What's signal flow? Well, if you pour water into a pipe, it's going to come out the other end, eventually, at some point, someplace. Well, as long as you think about this analogy throughout this lesson, you'll understand signal flow a lot better. In a previous lesson in our interface discussion, I'll link it up here, we talked about inputs and outputs. Your microphone connects to an input, your speakers connect to an output. Well, signal flows through that. My voice is an analog signal, and my microphone picks up analog signals and transduces them into electrical signals. Those electrical signals then hit my interface, which then gets converted into binary that the computer can understand. That goes into the DAW, and then I put a bunch of effects on it, and then it comes back out to my interface and into my speakers. That's signal flow, from my mouth to the microphone, to the interface, to the computer, back to the interface, back to the speakers. The order of which my voice flows through that entire system. That's what signal flow is. So we can think about each one of those steps, from my voice to the microphone to the interface to the computer, as stages. Well, what happens when we get into the DAW? There's many different stages. We have many different effects that we add to the audio, and each one of those effects is considered another stage. Our signal flow is how they flow through those stages. The order of which you place these effects changes the way the audio behaves. Again, the order in which you place your effects will change the behavior of the audio. So if you place one effect before the other, it will have one result. If you crisscross them, it'll have a different result. For example, think about a canvas. We have a white canvas, we have green paint, and we have black paint. If we go ahead and paint the whole canvas black, and then we paint a green line, then we no longer see the white of the white canvas. We only see a black with a green line on it. Well, if we decided to paint the whole canvas green and then paint a black line, now we don't see the white of the canvas anymore, and we only see a black line on a green canvas. This is the order of which we decided to paint. This same concept can be applied when we're processing audio. Our microphone is like the white canvas. It's the pure, unadulterated version of our canvas. And then whenever we put an effect on it, it's like a different color of paint. And whether we choose black paint or green paint first is going to change the outcome of our painting. Signal flow is the order in which the audio is processed, or the order in which you apply different paints. Now, without going too far into the weeds, if you use an EQ before a compressor, what you EQ will then be compressed. Now, if you use a compressor before you EQ, your EQ will change the dynamics of what you just compressed. The order of which you do things matters. Whenever we're processing audio, the audio travels through the system essentially in a single file line. My voice hitting the microphone doesn't come out of the speakers before it gets to the interface. It has to go through the interface to the computer, and then it can go to the speakers. The audio doesn't come out of the speakers before it comes out of my mouth. The audio doesn't get to my computer before it gets to the microphone. It has to get to the microphone, which goes to the interface, before it goes to the computer. The order in which the audio travels is our signal flow. A quick mention before we get into the next topic: make sure to head over to wavespot.com. I write all of this information down in blog posts. I also have all of the illustrations that I used in the videos. Fun fact, I actually release a blog post a week before I actually post a video. So if you're interested, you can actually see what I'm going to release next before we even get to it on YouTube. Even better yet, it's actually free. So if you're interested in learning more, head over to wavespot.com and don't forget to hit that like and subscribe button. Okay, moving on. So I've already kind of hinted at it. because audio flows through different stages. Stages, keyword there. This is our transition into gain staging. Well, what is gain staging? First, before we answer what gain staging is, we have to understand what gain is. So, what is gain? Gain is the adjustment of the dB level that enters and exits an audio device. Gain is measured in the dB, and I've already done a video on the dB, so I'm not going to go too far into it. So I'll post it up here if you want to click on it and get familiar with what the dB is. But for clarity's sake, it's the measurement of our gain level. We measure gain in dB. So since we're working in the DAW, and just for clarity of this video, our dB range is going to be -100, which is inaudible, all the way up to 0 dB, which is essentially the max that our computer can produce. Anything over 0 is considered distorted or clipped. So now that we understand what gain is, let's talk about gain staging. Well, we know what a stage is. It's the difference between my microphone, the interface, and all the different effects that we have inside of our DAW. Let's say that we're going to process audio and it enters our first effect at -20 dB. We process the audio and however which we will, and it comes out the other end at -15 dB. This means that our processing has increased the gain by 5 dB. So what do we do? What does this mean? Why is this important? Well, if we never gain staged anything and we continuously process the audio and it just continuously increase in gain, eventually we're going to hit that 0 threshold and we're going to start clipping. This is bad. Gain staging is good because it prevents us from clipping between our different stages. Gain staging. It allows us to compensate for the increase or decrease of gain whenever we're applying effects. All right, let's jump into the computer and I'll show you what gain staging is. So we can see our meter here. There's not going to be any sound. We're just going to do this visually for the first time. So if I hit play, we can see that our audio level is roughly in between this -18 and -24. It sits roughly at -20 dB right there. So what happens if we apply an effect that increases our dB by +5? Well, now we have that -15 dB from our earlier example. Well, if we continuously increased and then increase again, eventually we're going to hit that 0 mark. If we increase it again, now we're going to be clipping. Well, what's important about gain staging is that anytime there is an increase in gain, what we want to do after we're done processing it is we want to turn it back down. So now we can see here we have a +5, and then we compensated by adding -5. The audio goes in at -20. It gets increased by 5 dB to -15, and then we use the gain knob to turn it down by 5. This is what gain staging is. Now, what happens if we add an effect and there is a -5? What happens then? Well, if we add an effect and it decreases the amount of gain, what we can then do is we can change the position. We can add 5 to it. So the goal of gain staging is to match the input and the output gains. If the input gain is at -20, then the output gain should be at -20 as well. So let's take a look at why gain staging is actually important and what it can do if you gain stage correctly. So first off, this is going to be our tone that we're going to be using. So let's hear that. And you can see it's around -18 right there. Now, let's pretend that we added some different effects. And in this case, we're going to add a +5, and then another effect that is a +10, and then another effect that's also +5. What happens if we don't compensate and turn it down? Well, it starts to sound like this. And you can see now that we're clipping. And in fact, we're actually going 6.73 dB over 0. So we're positive 6, which is essentially bad. It's not good to clip your audio. And we discussed clipping in our last lesson. So if you haven't seen that, I'll tag it up here and you can go check out best practices for audio. So again, this is our clean audio. And this is what it sounds like when we don't gain stage. So in that example, we didn't gain stage at all. Now you can see here that there's a lot more effects going on. We have a positive 5 and then a negative 5 to compensate for that gain increase. We have a positive 10 and then a negative 10 to also compensate for that gain increase. Then we have another positive 5 and then another negative 5. Well, what happens when I play it now? It doesn't sound any different than when it started. And in fact, I can turn this effects chain on and off and you won't hear a difference. And that's why gain staging is so important. Here's another example, and this one's going to be fairly extreme, and why it's important to gain stage. Well, let's say our very first effect that we put on applies a positive 20 dB. That's already going to be above clipping. And if we don't apply a negative gain or turn it down, reduce the gain in order to compensate for what we just did, it's going to start off and the next effect already clipping. And then we're only going to add to the clipping. We're going to distort it more. So this is what happens when we have a plus 20, a plus 5, and another plus 5, but we don't compensate for that. You can hear how distorted it is. Now, what happens if we were to gain stage properly? Well, let's try it out. So what we're going to do, we see that this is a positive 20. We can duplicate it and then make that a negative 20. We hear that we already took the distortion away and we're not even clipping anymore because these two, the two positive 5s is only 10. And so in reality, we're only increasing by 10 dB. Now, without going into a full-on recording session and showing you each step-by-step process, this is the concept that I want you to understand. If you were to apply an effect and it increases the gain, make sure you check what it was before and then you match it to what it is after. If it comes in at negative 18 dB, it should exit at negative 18 dB. This prevents you from clipping going into the next effect. If you don't gain stage your audio, you can completely crush the sound before you apply another effect, and then you're only affecting a completely crushed sound. We want to make sure that however it comes in, it goes out, so the next effect can receive it in a good high fidelity state. If you found any of this information valuable, make sure to leave a like and hit that subscribe button. I release a new video every Monday morning. If you're learning something new, or if you still have questions, make sure to leave a comment and I'll get back to you. If you want to read more on the topic, head over to wavespot.com where I have more detailed information and all of the illustrations from today's episode written in a blog post. And until next time, thanks for watching.